This demonstration is about Lab 3 on scientific methods, where your objective is to determine what are the best predictor of lung capacity. As you noticed in the PowerPoint presentation, 3 objects were given. One of them is a weighing scale that can also measure your height, and a balloon, inflatable balloon, and a measuring tape. So these are the 3 devices that you have with the help of which your goal is to determine the lung capacity. And in that PowerPoint, I also talked about what is the tidal lung volume and what is the total lung volume. Normally, when you inhale or exhale during respiration, nobody can notice your respiration. So that amount of air that you can inhale each time and exhale each time is the tidal volume. That means that is not the full capacity of your lung. There is already some amount of air each time you inhale or exhale. Then what is the total lung capacity? Total lung capacity is the one when you completely exhale all your air from the lung, like, and then you inhale in one full breath. So that is a total lung volume. So the goal is you take a balloon to determine the lung capacity and you stretch the balloon from all sides, okay? And then you exhale all the air from your lung as much as possible. In other words, make your lungs free of air. And then you take full breath and you pump the entire air into a balloon. That means you transfer your entire lung volume into a balloon, and then you measure the circumference using the tape. So let's begin and see how much I can inflate. And all have to be done in one breath, not like in several breaths. So this is the maximum size I could get. Well, maybe you can get bigger, but this is what I could get in my case. So let's see what is my lung capacity. So now you tie it completely and you take a measuring tape and you measure the fattest area possible. And this measurement has to be in the centimeter, because in the science we work with the metric system. We work with centimeters, kilogram, not with inches or pounds. So here the diameter that came out of the fattest area is about 47 centimeters. So now I have the circumference of the balloon 47 centimeters. Then you provide your weight in kilograms and use your height in centimeters. And the formulas are given in the PowerPoint, and actually the table is given that has been collected from all the students. And with the help of this table that include the height, weight, body surface area, and lung capacity. So using these 4 variables, you draw 3 graphs, of which the dependable variable is the lung capacity and independent variable is height, weight, and body surface area. You prepare the graph, and based on how far the data are close to the line or farther from the line, you just make a guess what is your result would be. Whether you accept or reject the hypothesis. So you will not be knowing until you feed those data into the formula and get the exact R value. But try your best to accept or reject the hypothesis based on how those data points are. Are they closer to the line? Then you accept it. If they're farther from the line, then you reject it.